Hello everyone, and welcome to today's webinar, Predicting Costs with Amazon Web Services.
So today we're going to talk about the challenge of predicting costs with Amazon Web Services. We receive a lot of questions about this, and we put together this webinar to help you do a better job of doing that cost prediction. So we'll kind of jump in and we'll take a look at the various challenges inherent in understanding and measuring the costs of cloud-based computing. We'll talk about a set of principles and methodologies that I call the 5 M's. We'll review some of the tools that are available to you to help do your cost prediction. We'll spend a lot of time working through a number of costing examples, and then we're going to do as much live Q&A as possible given the amount of time that we have available. So what are some of the challenges that we face as we move to cloud services? The first big change that people notice is that the cloud model is pay-as-you-go. So the actual cost model of the cloud is going to be directly related to the amount of services that you consume. When you design the architecture for your cloud-based system, you get to make a number of different trade-offs that will basically control cost versus reliability, the number of instances you have running, the amount of redundancy you have across multiple availability zones, and so forth. We have the challenge of automatic scaling, where you can configure your application to scale up and scale down in response to changing load or traffic. We have the real challenge of viral applications, where you put your application online and it can be quickly passed from person to person in a situation that will then force you to scale very, very quickly. As you build your application in the cloud, you can make use of a number of different cloud services, and you can end up with a rather complex architecture with a number of different cost components and cost drivers. You might also find that some of the parts of your application turn out to be rather expensive features, and that they are relatively high consumers of resources relative to the value that they provide. When you build your application with the cloud, you often can build it and put it online fairly rapidly, so that the challenge of understanding your costs in that relatively short amount of time you have to design, build, and deploy is also present. And we also have the challenge of continuous deployment. You conceive of new features, you implement those, you put those online, and you don't always have time to do a complete and thorough analysis of the cost implications of those new features. So see, these are some of the things that we hear from our customers as the challenges that they face. On the other side, there's quite a number of new opportunities for you. The first is that because the cloud is pay-as-you-go based pricing, you have the opportunity to have very detailed visibility into your costs. The cloud is economical, and it offers you the opportunity to have dramatic cost savings. And it also lets you price your application according to your costs, so you can be very aggressive with your pricing once you have a full and complete understanding of your actual costs. One interesting thing you might want to think about is that when you do understand the cost at the feature level, we're going to talk about ways that you can actually measure the cost at the feature level. You can consider having a premium charge for the features that are expensive for you to actually to operate. This opens the door to new business models. And also something I've emphasized in my talks for several years is the fact that because we have a pay-as-you-go model and because you can build a very scalable system, you should be able to construct businesses that are going to be profitable at any scale, because you don't have what has traditionally been the enemy of profitability, the very large fixed costs. So here are some questions I have for you, and these are somewhat hypothetical questions in that I haven't yet met any business or entrepreneur that really knows these questions in detail, but these are goals to strive for. So I would ask you, do you know on your current system the cost that you actually incur for your user to do a single search? Do you know what it costs to actually support one page view? Do you know what it might cost to store one inventory item? Do you know what the costs are when a single search engine visits your site and requests hundreds or thousands of pages from your site? Do you know what it costs to support a single user? And then, if you don't know these costs, I have to ask, does your competition know? So we're going to go through some fairly complex situations here, and we're going to talk about some math, and typically that tends to scare people a little bit. So I would offer you the reassurance. I say, don't despair. We're going to go through this step by step. It might seem a little complex at first, but I don't think you need to do everything that I talk about here in your first iteration. I really want to encourage you to just ease into this process. Go step by step, do a little bit of measuring, get a little bit of understanding of your system, and then after you master that, just keep on going and go from the point where you don't have any cost understanding at all to a gradual improvement in your ability to understand and predict your costs. What are some of the cost drivers of running on AWS? These are some of the main components. You're going to be running a number of EC2 instances, so you're going to be charged for CPU clock hours. You're going to be storing some data, so you're going to be charged for persistent storage. You're going to be reading and writing data to and from elastic block storage volumes, so you're going to be responsible for I/O requests both directly to EBS and through the relational database service. For long-term usage of EC2, you're probably going to be making use of the reserved instance model. And in certain kinds of applications, you're going to be making a number of requests to the various AWS APIs. And finally, your application is going to be transferring data both in and out of the various services. We do not charge for data transfer into AWS, so you don't have that as a cost driver. However, we do charge for data transfer from AWS to the outside world, so that's going to be your responsibility. So that's an important cost driver for you. So what are the different things you need to worry about? These are what I call the 5 M's: modeling, monitoring, measuring, multiplying, and mastery. So we're going to review each of these in turn. Let's start with modeling. The idea with modeling is you want to have a good understanding of your system on a functional basis. You want to know all the different components that contribute to costs. You want to have a good understanding of your architecture. And you want to then use this detailed understanding to construct a cost model. Here's how you go about doing that. You start by identifying the various user-level functions and the frequencies with which they're performed, things like login, a search, a page view, a hit from a search engine. You then trace these through your architecture, and you understand the implications as far as resource consumption on your web server, your database server, your messaging, your storage, and so forth. With that understanding, you can then start to identify and isolate the various cost components. You can understand how much CPU power, how much data storage, how much bandwidth each of these different functions is going to consume. With those cost components understood and with the relative frequencies understood, you then have the raw data to construct a cost model. And mathematically, we're saying we're going to take the various resources, multiply those by the associated cost per resource, and then sum those up, and that should give us a model, a parameterized model of the cost of operating our site. Another methodology is to measure. So how do we do that? So the first thing that we talked about, the modeling, was kind of an architecture-driven approach. This is more of an operational-driven approach. So what do? We start by isolating a functional component once again, login, search, page view, or a search engine hit. We're going to run it in some kind of a controlled environment, a test harness that lets us do a multitude of that one particular function. As we do that, we're going to track the resource usage that's implied by that particular function. We can do that in a number of different ways. We can use Amazon CloudWatch. We can look at the metrics tabulated in the AWS account. We can look at various low-level server logs, and so forth. Again, once we have that raw data, we can map that resource consumption to costs, and we can do that using the published AWS prices. So here's what I'm kind of driving at as far as what you might want to achieve if we were to measure different aspects of a system. So let's say we have page views, creation of a new user, and then retrieval of an RSS feed that's offered by the site. The goal of measuring would be to understand for each of these different operations or functions the amount of usage of each of these. So we've got CPU usage, bandwidth, storage, and database queries. These are all approximated numbers that I made simply as an estimate of the complexity of an imaginary application, but the idea is that this should be, in your own application, you'd have the ability to measure this with a high degree of precision. So we can see that each of these different operations has different implications as far as the amount of resources that it consumes. Once we have those those basic frequencies and we've made those measurements, we can go to the next phase, which is multiplication. So we're simply taking the frequencies and multiplying by the measurements. And we can say for each of these different operations, we can say, if we're doing create user, and we can then multiply the basic resource usage of each of these by the actual frequency with which they occur. So if we say create user has a certain resource consumption and we expect to create 1,000 users per day, we can then get the aggregate amount of CPU usage, bandwidth, storage, and database queries that we expect as a result of that 1,000 user creations per day. Once we have that, we have mapped our resource consumption to our costs. This is relatively easy to do for storage and bandwidth. It's going to be a little bit more challenging, but still achievable for your CPU usage. Monitoring is the act of going in with a high degree of precision and doing your best to understand the actual resource consumption of your application. The idea is that you typically want to be able to watch your costs as they change. So the first step here is you're going to want to establish a cost baseline. You're going to want to know under whatever's your basic operating scenario, a regular traffic day, you didn't have any particular spikes in traffic, you're just at your regular scale, your normal level of growth. So you want to know what your operating costs are under that scenario. And then you want to start to watch for deviation. So what the challenges that you might want to worry about as you're doing your continuous deployment, as you're putting new features into your code, you want to be really, really aware of the fact that as you add those new features, perhaps they have a surprising effect on your resource utilization and then on your costs. So this gets you into the situation where you're going to start considering cost implications of the changes to your code. Perhaps you're storing additional data for each user, or you have been generating that RSS feed and you, for some reason, decide you need to just do one additional database query for each feed. The idea of these very fine-grained techniques that we've been discussing here today is that you should be able to measure and understand and track these additional costs as you make these changes to your system. So we've gone through 4 of the M's, and the last one I call mastery. So we've covered quite a bit of ground there in just a few minutes, and I'll be the first to admit there's plenty to learn. There's probably time for this to be almost it's almost a science of its own, just doing all these different measurements and getting this very detailed understanding of your system costs and performance. On the other hand, I do believe you can start small and you can grow over time, get the first level of handle over your costs on understand a single function or understand it on a course basis. Get that first level of success. Start to compute some expected costs, and then test your model as you scale and say, okay, we believe that our costs will go up at this level based on adding new users, adding additional items to our database, and so forth. Start to check those calculated results against actual. Use those to fine-tune and to add detail to your model. And then accumulate some experience and knowledge as you go in order to make that model even better, to get a better grasp of how your system operates and how those different operational attributes and quirks to your system then actually correspond and correlate to costs. The next question is really, how can Amazon help? What are the various costing and monitoring tools that are available? So we have a number of different tools that should be helpful to you. These include the AWS Calculator, where you can enter in your estimated usage of the different services on a very, very detailed basis. And the calculator will then let you model out various different kinds of scenarios, and it will then compute for you the expected cost for the resources in those different scenarios. You do have the opportunity to log into your AWS account, and there's 2 different forms of information that are available to you. The account activity page will give you the summary of your charges per month on the basis from the beginning of the month to the current time, the amount of resources you've used of the different services, report section of the website, and you can download very, very detailed usage reports in either CSV or XML format. You can then use those as input to your modeling process to do various what-if computations based on these usage reports. We also give you a very, very important service called Amazon CloudWatch. It gives you the ability to monitor a number of different aspects of your system. You can use CloudWatch to inspect very, very fine-grained metrics of the different aspects of your cloud-based architecture. And the last monitoring tool we'll talk about today will be the service logs. So services such as Amazon S3 and CloudFront both give you the option to enable logging for the service. Once you've enabled logging, you route the logs to a particular Amazon S3 bucket, and then all the accesses that are made to your objects that are stored in Amazon S3 with optional content distribution through CloudFront, all those accesses will be logged to the logs. You can then retrieve those logs, and you can process those with a log analysis program. Now let's go into some details of some actual site architectures, and we'll see how we go from a simple static microsite to a simple dynamic site to a more complex load-balanced auto-scaled dynamic site. These are examples that I put together for the purpose of this presentation. Of course, your mileage is going to vary. You're not going to find your site mapping exactly one-to-one to these. The idea is really to work you through the process, work you through the methodology, and give you a better understanding of how we do the cost estimating. Let's start out with talking about the static microsite. So the static microsite will be stored in Amazon S3 and then distributed worldwide via CloudFront. The microsite consists of a HTML page, a single style sheet, a JavaScript file, and then 50 JPEG files. So a total of 53 separate objects totaling 1.1 megabytes of storage. Here's the operational architecture. We store all of those components in an S3 bucket. We have our S3 bucket down at the bottom here. And then we make a CloudFront distribution around that bucket. As our users to the microsite from around the world access the contents of the microsite, it's automatically updated in the CloudFront edge locations worldwide that are closest to those users, and our microsite appears in the users' browsers. So very, very straightforward. Static content into the bucket, out through CloudFront, out to the users' browsers. So how do we go about tabulating the costs? So we start doing some calculation. And very, very conveniently, we find that we're storing 1/1000th of a gigabyte. And then we decide that for our microsite, we probably update it twice per month. Because we are charged in Amazon S3, we are charged for the number of put requests we make for our content. We have a total of 53 objects and currently 19 separate CloudFront nodes. And then based on the caching behavior and the numbers we've looked at from our logs, we figure that on average we're probably updating those nodes about 10 times per month. So that's our basic data. We take that data and we enter it into the calculator. And then we do some additional calculations for CloudFront. So we estimate, based on our own knowledge of our site, that we're going to get about 1 million page views per day. That's actually a fairly busy site. If you can get your site to the point of 1 million page views per day, you're doing quite well. We then compute 1 month's worth of data transfer. So we take the fact that we're storing 1/1000th of a gigabyte. We're going to transfer for 30 days, and we're going to do 1 million of those transfers per day. So that gives us a data volume of about 32.25 gigabytes per month. The final estimate that we need to make, and this can only be driven by your knowledge of your audience and informed by your inspecting of the log files, is the location of your users around the world. So you can see here at the bottom of the screen, what I've done is I've estimated the locations of the users, and I have used that to then drive a distribution of traffic. So I'm saying here that I expect 50% of my traffic to come from the US, 25% from Europe, 10% from Hong Kong, and 15% from Japan. This is important because there are different costs associated with delivering content to different parts of the world. So with all this data entered, we can plug all that into the calculator, and we can see that our total cost for this microsite, where we're serving up 1 million page views per day, our storage costs plus our data transfer costs through CloudFront are $5.93 per month. So there we went from content to architecture to estimations of usage, to estimations of geography, and we use that to drive this calculation. Let's move up from that static microsite to a simple dynamic site. So the architecture that I have here, we're going to have a single EC2 instance that runs both the application and the web tiers. We're going to expect 100,000 hits per day on that site, and we expect that we're going to deliver about 50 kilobytes of data in response to each of those requests. We're going to use a single relational database using Amazon's Relational Database Service, and we're going to use that for our primary storage. We expect to store 50 gigabytes of data, and we expect about 10% of that data to change or churn each day. We're going to use RDS to arrange for daily backups of that data. So we're going to store 50 gigabytes of data, and because about 10% changes per day, we're going to expect that our snapshot backups are going to be on the order of about 5 gigabytes per day. So the first step is we're going to compute our EC2 costs, and we're going to be running this on an M1.small instance, and we're going to use the ephemeral storage, the storage that's local to the machine. So we're going to, again, do some multiplication. We're going to figure 100,000 requests per day, 50 kilobytes per day, times 30 days, gives us 150 gigabytes per month of data transfer. Now we also need to estimate the cost of using RDS. We're going to use a small RDS instance, and then there's a little bit of estimation here. I estimated that our data, that each hit on our website is going to result in about 5 IOPs, or input-output operations, per hit on the site. This is something that has to be determined by measuring. Each site is going to be different, and you'll need to do some analysis and some measuring of your site in order to come up with the number that's representative of the relationship between the hits and the IOPs on your particular site. So we then, again, do multiplication, and we come up with our 100,000 hits per day, the 5 IOPs per hit, the 30 days, and we come up with 15 million IOPs per month. We enter that into the calculator along with our 50 gigabytes of provisioned storage, the number of IOPs, and we estimate that we're going to need about 40 gigabytes per month of storage. That 40 gigabytes comes from the fact that we are going to do a 5 gigabyte backup every day, and we're going to set the retention period to be 8 days on there. So that gives us an average of 40 gigabytes per month of storage. So we put that all together, and what do we see? We see that our costs are going to be composed of some EC2 costs, and we're going to also have some RDS costs, and we're going to have some data transfer costs as well. So the EC2 instance, the RDS instance, the data transfer, we add that up, and our simple dynamic site is going to cost us $177.74 per month. So my hope and my expectation here is that this is going to start making sense to you as we go through from the very simple site to the simple dynamic site to the more complex site that we'll cover next, and that you can start to see how you'll be able to apply this to your own situation. So let's talk next about the complex dynamic site. An important attribute of the complex dynamic site is that it is actually changing. So the number of EC2 instances that we have running over time is going to actually be auto-scaled up and down in response to changing conditions. We're going to run, again, both our application and our web tiers on EC2. And we're going to expect that our site has anywhere between 10,000 and 1 million hits per day. And once again, we'll use the 50 kilobyte average response. And then based on our experience and some measurements that we've done outside the scope of this exercise, we're going to assume that one small instance can handle 10,000 hits per hour. We're going to stick with our single RDS DB instance. And again, this time we're going to say we've got a 100 gigabyte database. We're going to expect 10% churn. And once again, we're going to do a daily backup of that database. So this is the architecture that we're describing here. We're going to actually go for a multi-availability zone RDS. We're going to have both the primary and the secondary. And we're going to use what's called an auto-scaling group. And so we're going to be able to automatically scale our EC2 usage anywhere from 1 up to 10 instances based on our load. In front of that auto-scaling group, we're going to place an EC2 elastic load balancer to smoothly distribute traffic across the set of healthy instances in that auto-scaling group. We'll do a daily snapshot backup of our database, and because we're again assuming the 10% churn, we'll assume that we have about 10 gigabytes per day of RDS database snapshots. So as I described before, we are anticipating a variable load on this site. So the question is, how do we actually model that? So what I've done here is I've got two separate graphs superimposed. In the blue lines represent the expected number of hits per hour in thousands to our site. So you can see that there's basically two peaks. We have a peak kind of around hour 9 and a more moderate peak around hour 18. So those are the blue lines. And then the red lines, they're down at the bottom, represent the corresponding number of EC2 instances that we will need in order to serve up that traffic. Remember, we decided that each instance could serve up 10,000 hits per hour. So this nicely rounds up to exactly 1 million total hits for the day and 100 instance hours. So I carefully chose these numbers to give us nice round numbers for ease of calculation. So when we look at this, and we actually do a little bit of summing across the day, we say we're going to be running 100 instance hours per day and then 1 million hits per day. Now, the interesting thing to think about when we go back to the graph for a little bit is the total hits and the instance hours are reflective of the dynamic pattern. If we had a different dynamic pattern, it might actually add up to the same number of hits but spread out over a different time period. Maybe we only have one spike and it's far bigger than we maybe have one big spike at hour 8 and we don't have any spike at hour 19, let's say. But for the purposes of this exercise, what we really care about is simply the total hits and the total number of instance hours that we require. So we're able to trade off the number of instances running, and we simply are paying a cost per hour for those instances. So a little bit more multiplication, and we're going to be doing 50 gigabytes of outbound data transfer every day, and we're going to be processing 5 gigabytes of inbound transfers per day. And again, because we decided that we're going to do 5 IOPS per database or per hit on the site, we're going to take the 1 million hits per day, multiply that by 5, and we'll get 5 million RDS IOPS per day. So now we start entering this into the calculator. So now we have this magic number 4. So the 4 represents the fact that we need essentially 100 hours of EC2 per day. And so I'm saying 4 full-time instances, so that's 4 times 24 or 96, which is close enough for this exercise to the 100 hours per day. We're going to then do the 50 gigabytes of data transfer out and the 5 gigabytes of data transfer in. We enter that all into the calculator. Also at the bottom, you can see that we are entering in the fact that we need 1 elastic load balancer. Let me highlight that for you. We're going to need 1 elastic load balancer, and that we're going to transfer a total of 55 gigabytes of data in and out through that elastic load balancer. We also need to enter in the cost of our relational database instance. So we're going to use a small RDS instance. This time we're going to use a multi-AZ instance so that we have both a primary and a secondary instance with automatic failover from primary to secondary. We have the 5 IOPS per hit on the site, which gives us, according to the math that we've already done, 5 million IOPS per day. We provision 100 gigabytes of storage, and so doing all the math, we come up with 120 million IOPS per month. We enter this all into the calculator, and we can see our EC2, our RDS, our data transfer costs all in here. And this adds up for this complex dynamic site serving this large number of hits per month and with auto scaling up and down. We're at $502.15 per month. Okay, so that is the conclusion of my prepared material, and now what we'd like to do is switch into Q&A time, and I'm really looking forward to your questions and hearing what you thought and to giving you additional information based on your questions.
Hey, Jeff, we had a quick question from Mikkel. Can you go back to the complex dynamic site and the data transfer in? Did you have a cost for the dynamic transfer in when you were costing it?
So the inbound data transfer to AWS, there is no charge for that. So that is not reflected in the cost. That's free for our users.
Okay, great. All right, thanks so much. We just have a question from I think it's Michelle or Mikkel. It says that you're running on large numbers. Can you show us on lower numbers? That is the average we get every day. Can you just talk about how they can use sort of what you talked about with different numbers to still be able to get accurate costs for what their particular sites will have in terms of traffic?
Certainly. So a couple different recommendations there is that I think that this methodology should apply at any scale. I would recommend that if you're starting out very, very modestly, then you could start instead of the EC2 small instance, you could run with the micro instance. So their part of your calculation is made even easier by the fact that we also have the AWS free tier, which gives you access to a micro instance for a year at no charge. So at the very low end of how much would it cost, you can run a moderately sized site at no cost.
Great, thanks. The next question was, can you talk about the free tier a little bit, Jeff, and how that factored into the way you costed today, and maybe why it did not apply to some of the costs you gave?
Let's see, why did it not apply? So I was trying to make kind of a representative set of long-term costs here, and so I explicitly, when I was in the calculator, I actually turned off the free tier. So I was trying to give you the free tier certainly improves the cost. You get a certain amount of EC2 time, you get bandwidth, you get access to a number of services at no charge. But in order to give you, I don't want to say worst case, I want to say the realistic case, once you have gone beyond the bounds of the free tier, I took that out of the calculations.
Yes, absolutely. And I think you would have been probably utilizing the free tier the most in your first architecture, which was the static website.
That's right.
Especially in terms of the S3 usage.
Right. I could have kind of cooked the numbers a bit and come up with examples that didn't go beyond the bounds of the free tier, and that would have been, I think, wonderful advertising for AWS of effectively, look what you can do for free. But my sense was that wasn't really good for the audience because they really want to know, once I scale beyond free, what are my costs? So I was trying to really kind of think toward for the audience's benefit rather than for the benefit of AWS there.
Absolutely. On that thread a little bit, can you just talk about maybe if someone's trying to build a smaller application for free, some types of applications that might be well suited to the free tier?
Sure. Why don't I actually bring up the free tier webpage? It might be a good way to do that here.
Yeah, that's a great idea.
So that's aws.amazon.com/free. So the AWS Free Users tier gives a number of gives access to our customers for a certain amount of AWS resources per month. So let's go through this to just review. You get 750 hours on a EC2 micro instance. So 750 hours is enough to run that instance continuously for the month. You get 750 hours of the Elastic Load Balancer, again, enough to run it full-time for the month, and then 15 gigabytes of data in and out through that load balancer. You get 10 gigabytes of Elastic Block storage, and then 1 million I/O operations, a gigabyte of snapshot storage, and then a certain number of requests, both GET and PUT requests, to that storage. Within the free tier, you also get 5 gigabytes of S3 storage, along with 20,000 GETs and 2,000 PUTs. You get 30 gigabytes of internet data transfer. That's 15 gigabytes in and 15 out. And you get access to Amazon SimpleDB for 25 machine hours. You get access to the Simple Queue service, and then the Simple Notification service, and the ability to store up to 10 Amazon CloudWatch metrics. So this is all available to you at no charge within the AWS Free Usage tier.
Great. Thanks, Jeff. I got a couple questions from Robert that I'm going to link together. Robert first has a question about the redundancy of the architectures you showed, which ones are redundant, which ones aren't. So we talked just a little bit about reliability, and then he also says, do you offer prepackaged architecture so we don't have to build it ourselves? Maybe it'd be good to touch on Beanstalk and Cloud Formation for him.
Sure. Okay, Robert. So one of the things that I talked about early in the webinar was the fact that you, as the architect of your system, get to make some trade-offs of the amount of redundancy in your architecture, and then as a result of the amount of redundancy, you're going to control the amount of durability, and then durability and both availability of your architecture. So in the simple dynamic site that I showed you, I had a single EC2 instance. So a single instance would be running in a single availability zone. So if anything were to happen inside that availability zone, that was, if your instance were to stop running, or if you lost connectivity to that zone, then your site wouldn't be accessible. In our recommended architectures, we always say that you should go for high availability. You always want to have at least one instance running in 2 or more availability zones. When you do that, you can do things like you can run a single elastic load balancer in front of those multiple instances, and then it'll automatically make sure that it can reach those instances and then route traffic to the instances that are considered healthy and connected. We do have an AWS Architecture Center with recommendations for how to go about building these highly available architectures. So that's aws.amazon.com/architecture. On that site, you can also find a number of white papers, and we also have some links on there to some webinars that we've recorded earlier this year about a number of different ways to build these highly available applications. Let's see. Also, Reed asked about, there's 2 other services we have that might also be helpful to you if you want to easily build highly reliable applications. Let me bring up the AWS console here. So the AWS Management Console, I'm going to sign in here, and I'm going to start with the EC2 tab. The AWS Management Console gives us access to our services, all from our browser. So I'm going to talk about 2 different services. The first one is called Elastic Beanstalk, and the second is called Cloud Formation. So Elastic Beanstalk is the first tab on the console. With Elastic Beanstalk, what we allow you to do is you can simply create an application, compile that application locally, and then you upload that application to Elastic Beanstalk. We will then take care of creating the EC2 instances, creating the auto-scaling environment, creating the load balancer, of updating system software on the instances. You can configure in auto-scaling parameters into your application. And so we'll effectively give you a default architecture that makes it very easy for you to simply build the application, put it online. We'll take care of all the details for you. We currently support Java-based applications. You compile your Java application into a WAR file, and then you simply go to the Elastic Beanstalk console and you create you click the Create New Application button, and do that from here. Test application for webinar. So we can go through just a wizard, a couple of steps, and we can then create that Elastic Beanstalk application. We can run it on both either 32 or 64-bit Linux, and we can run it either under Tomcat 7 or Tomcat 6. So Elastic Beanstalk will take care of a number of the details for you of putting your system architecture together. Another approach we have is called AWS Cloud Formation. And let's click on the Cloud Formation tab here. The idea with Cloud Formation is that we operate a number of stacks. And we can simply, each stack is described by a template. We have a number of built-in templates for a number of common software packages, and you can also create your own set of templates to describe the complete stack. So the CloudFormation stack, and I'm going to actually go out and try to find my blog post on here. The idea of a CloudFormation stack is that in a single template, you start like this. Let's say we have a desired architecture, and we might need an auto-scaling group and some EC2 instances, some database instances, a simple DB domain, and so forth. We define that desired architecture. We describe it in a declarative template, and we then load that template into the console through the CloudFormation tab, and then CloudFormation will take care of creating all the different components needed to realize this architecture. It will create them in dependency-based order for you, so it'll figure out which pieces it needs to create first, second, and so forth. And it lets you then actually realize the architecture with a couple of clicks, and then have control of that entire architecture as a unit. So for example, if I go back to my console, I have created several stacks in the past, and each of these different stacks I can see here, I create, and CloudFormation actually tracks the complete set of resources associated with my stack. So all I did was launch a single template, and CloudFormation created a security group, a load balancer, it launched a relational database, it created a CloudWatch alarm, and a launch configuration for auto-scaling, and so forth. So Cloud Formation makes it very, very straightforward to describe that architecture, define the template, and then create one or more copies of the architecture described by that template by simply uploading the template into Cloud Formation. Great question, by the way.
Great. We actually had another question that was very similar, so we addressed a couple there. The next question is from Angelo, and he's actually talking about using Microsoft SQL in terms of if that was the server on the complex dynamic site, how would that work in terms of supporting auto failover, or in this case, synchronous or asynchronous replication with Microsoft SQL?
Okay, Angelo. So there's a couple of different ways to run databases on AWS. The first one, and the one that I covered in my example, used a service that we have called RDS, or the Relational Database Service. I'm going to bring up that tab right here. With RDS, you create what are called database instances, and you do that through the console. We currently support MySQL and Oracle databases through the Relational Database Service. When you create them through RDS, we take care of allocating the hardware, installing the operating system, installing the database, arranging for snapshot backups, arranging for automatic failover, and so forth. We also make it very easy to scale your database up and down. So this is effectively a hosted form of these relational databases. So we currently do not support SQL Server within RDS. However, you do have the ability to launch an EC2 instance that has SQL Server on there and ready to go. When you do that, you're effectively just launching a server. SQL Server is there. It's going to be all set, and it's going to be running. It's not going to be running inside of the relational database service, so it is not going to have the automatic scaling up and down. It's not going to have the built-in failover, and so forth. We certainly have received requests for a number of additional databases to be supported in the relational database service, so over time, we'll undoubtedly add additional databases to what's supported.
Thanks, Jeff. The next question is from Tony. Tony wrote, is it more cost-effective to bundle a smaller number of instance sizes to meet his application requirements, or does he need to use the minimum amount that will meet his application requirements? And so he is an example. It says if he needs 3 gigabytes of RAM, should he bundle 3 1 gigabyte instances, or should he use the instance that it has at least 3 gigabytes of RAM?
Oh my, okay.
I think one of the better ways to potentially address this is just sort of talk about vertical versus horizontal scaling with the Amazon EC2.
Yeah, so I hate to have to say this, but the answer to that is really going to be, and it depends. It's going to really depend on, is your application very CPU intensive? Is it I/O intensive, either to the disk or to the network? And if you find that a single instance has the CPU power and the I/O bandwidth to support all 3 of your applications, then it's certainly reasonable to think about putting all 3 of those on a single instance. However, generally when we talk to our customers that are at the mid-range to the large size, they typically think in terms of horizontal scaling, where they typically want to use individual instances to support individual application functions. They do this for isolation purposes, logical isolation, security isolation, for ease of updating, where they can update single applications really easily. And they typically think more in terms of this logical structure than about kind of squeezing out every last little bit of efficiency from a single instance. We do give you the ability to really do both, though, because we do have 11 different sizes of instances. When you launch your EC2 instances, there's a choice of 11 different sizes there. So if you want to effectively just vertically scale, and you want to just take a single machine and won't put many applications on it, you certainly have the ability to do so. If you want to horizontally scale, and if you prefer to keep each application on a separate instance, you can do that as well. So my recommendation would be decide on the degree of isolation that you expect, that you would like to have between the instances. If you're okay co-locating them, then put them on a single instance as long as you have enough CPU power and I/O bandwidth to support those combined applications. And also think in terms of what happens if you start with 3, but that maybe one of those wants to scale, and you say, well, maybe one of those has the potential to be a runaway success. Are you okay having it wrapped up inside of the same machine with two others that maybe don't want to scale, don't need to scale, or would you prefer to have it isolated so that when you need to scale up, you can individually scale up that individual application without interfering with the other two? Great question. I hope that gave you some useful guidance there.
Great, thanks, Jeff. Our next question is from Kalai Selvin, and I apologize if I did not pronounce your name correctly. He's basically looking to, in terms of estimating costs, if he supplies the same number of parameters versus the current data center, will he be able to show the ROI when he goes to the cloud? And then whether that's possible, and it says in the tool, I'm pretty sure he's talking about the calculator. I think what we might want to address here is operational versus fixed costs and the real total cost of ownership of some of the other items that might go away in terms of current on-premises deployments when moving to the cloud.
Sure. Okay, so generally what you're going to find is that when you have a cloud-based solution, you have the ability to have a very, very complete understanding of all your costs. You can put all those costs into the you put your usage estimates into the calculator. You can see the estimated costs. You can then look at your bill each month, and you can see exactly what you're paying for your storage, for your bandwidth, for your instances, and so forth. So you can see the bottom line. Data centers is that these costs are actually not as well understood. So most organizations we've talked to, and we've talked to quite a few over the years, they'll make some fairly good estimates about their costs, but they tend to, there's a certain number of things that are just kind of hand waved away essentially as overhead. And if you really want to get down and dirty and say, do I have a full and complete understanding of my local data center costs, you need to just pick out all those different overhead items and make sure you're actually being charged for physical facilities and for power and for security people and so forth. And also you need to start making get an understanding of your operational expenses. Are you simply, what are you paying for by the month, versus capital expenses where you've made a long-term expenditure and you have a large fixed cost for your data center and for your physical equipment in your plant and so forth.
Hey, Jeff, could you quickly just go to the Economics Center and
Sure.
show them what's available for I mean, that whole site sort of focuses on TCO specifically and analyzing one versus another. Obviously, this webinar mainly just focused on analyzing what your costs would be with AWS. Specifically, not how to analyze what your current costs might be for an on-premises deployment.
So I went to aws.amazon.com/economics, and the Economics Center gives you some guidance. Also kind of walks you through the traditional data center model versus the cloud-based model. And we have a number of resources available for you. We have a number of cost comparison calculators. We have a white paper about economics of the cloud versus owned IT infrastructure. And all these should actually be pretty helpful to you as a guide as you start to try to compare and contrast the two.
Okay, Jeff, our next question is from Alexander, and he says, when does Elastic IP come into play? Is this not relevant for costing? And in most cases, maybe one of the ways we can address is talk about ELB and Elastic IP and when to use one or the other or both in terms of some of those deployments.
Okay. So the concept of the Elastic IP is that in certain cases you need a fixed IP address that will be invariant even as you change the EC2 instance that is behind it. Sometimes if you're talking to your corporate data center and you need to set up a communication link back and forth, you want to have a fixed IP address so that they can then open the firewall on the corporate data center side. So the Elastic IP you allocate once, and then you can map it to any of your EC2 instances in a particular region. You only pay for Elastic IP addresses if you have allocated it, but you are not using it. So if it's effectively an IP address in reserve, then you're charged 1 cent per hour for that IP address. If you allocate that IP address and you're actively using it, there is no charge for it. So we need to contrast this with the Elastic Load Balancer. So an Elastic IP address is always pointing at a particular EC2 instance, or it's unallocated, so it's not mapped to any particular instance. An Elastic Load Balancer is in front of a any number of EC2 instances. The elastic load balancers are accessed by DNS name because there's actually redundancy inside the load balancing system. So when you say I'm communicating with a particular load balancer and you reference it by DNS name, there's actually automatic failover inside. So that one conceptual load balancer, there's actually multiple load balancers available to you. So because of that, you access it by a DNS name rather than by an individual IP address. So any kind of an auto-scaling system is always going to use an elastic load balancer and probably won't have need for elastic IP addresses. Hope that all makes sense for you.
Okay, thanks, Jeff. The next question is from Mark, and he says, basically, how do I create a disaster recovery for a server instance? What if the server goes down? Is the instance data restored automatically, or does it have to be managed separately? I know we've talked about that a little bit. Maybe we can continue talking about
Sure.
How to build reliability into application architectures.
Okay, so Mark, one of the things you should know about is what's called the elastic block storage volumes. So when we create our EC2 instances, there's a certain amount of storage on the instance. That's called the ephemeral storage. The ephemeral storage has the same lifetime as the instance. So as instances are come and go as they are created as a result of autoscaling and then shut down later as a result of autoscaling, that local storage on the instance isn't going to persist. So we have a separate kind of storage called elastic block storage, or EBS. And with EBS, and I'm pulling up the console here, with EBS we can create virtual disk volumes, and we can create those in any size from 1 gigabyte up to 1 terabyte. So I could create a small one, just created, let's say, a 5 gigabyte volume right here. So I create that 5 gigabyte volume, and then the next step that I do is I can simply click on that volume in the console, and I say attach. And I attach that volume to any of the instances I happen to create in a zone where I didn't have any instances running. But I can then attach that instance, that volume, to any of my EC2 instances. I can format it, I can put a file system, I can do my data storage. So if the original instance were to fail, the replacement instance would simply need to be reconnected to the existing volume. So you can make data storage with EBS that is more of a longer lifetime than of a particular EC2 instance. Typically, in a failover scenario, what you'll do is you're going to do some level of scripting so that when the instance launches, it's able to consult the environment, it's able to figure out what data sources it needs, attach those data sources, and typically we see our customers building these kind of almost self-managing instances where they will consult configuration data and then they will set themselves up in the proper configuration at startup time.
Okay, thanks, Jeff. Jeff, James is probably going to be our last question of the day. He says, are there any special considerations for a startup that is prospectively estimating costs for fundraising? And basically, similar, are there any white papers for the obvious and non-obvious pieces of AWS that one might want to build into these calculations?
I don't think we have anything special for startups because there's such a wide variety of kind of architectures and aspirations for a startup. So it's really hard to say here's how much it will cost to run your startup on AWS. I think the methodology that we talked about is totally applicable to startups. Probably a very important aspect is the fact that you're not going to be investing up front in capacity. You're not going to have to spend your capital on servers that you might or might not need. And then in the very early stages of your startup, as you're building and as you go up to your initial deployments, you're going to be consuming very modest amounts of resources until you hit that point when you're ready to start scaling up and attracting a larger sized audience.
Great. Thanks, Jeff. Well, that's going to wrap up today's presentation. So on behalf of Amazon Web Services, I want to thank you for joining us today to learn about predicting costs on AWS.